Hello, my name is Dimitar Marinov and now I'm going to talk to you about my third year project entitled Generating Summaries of Social Innovation Projects. First let's start with a definition of what social innovation is. According to Soma, Hotter and Clevier, social innovation is the process of developing and deploying effective solutions to challenging and often systemic social and environmental issues in support of social progress. An example of social innovation projects held in the UK is the Real Junk Food Project. Its aim is to collect food that otherwise goes to waste and feed homeless people with it. My project is part of a bigger one called NOMAC, which is a project distributed among several universities around Europe, and it's funded by the European Union's Horizon program. Um, an enormous database of social innovation projects has been collected since 2017 when this project started. Information extracted has been stored in it, such as project, the name of the project, organization, actors, topics, etc. Now the guys from NOMAC want to store a short cohesive description summary that mentions the key facts and topics about each of those social innovation projects in the database. This is basically the aim of my third year project. So before digging deeper, I just wanted to say a few words about how text summarization tools can be classified. So as you can see, we can classify them based on the input type, which can be single or multi-document, and I think this is pretty self-explanatory. Then we have based on the purpose, which can be generic, where the models makes no assumptions about the domain or content of the text to be summarized. Next, domain specific, where the model uses some prior domain specific knowledge about the input text. And finally, we have query based, where the summary just consists of answers to natural language questions. Then we can classify those tools based on the output type, which can be extractive or abstractive. The extractive way of doing this is by selecting different sentences from the original text and concatenating them in order to form a summary, while the abstractive approach is when the tool comes up with its own interpretation of the summary. In my case, I'm going to have a single or multi-document input because, as you know, web pages contain several pages in them. Then we have domain-specific purpose because I'm going to be summarizing social innovation projects only. And finally, I've decided to stick with the extractive output type because in order for me to go with the abstractive approach, I would have to have an enormous database of such projects and summaries, and unfortunately, I don't have one. Next, here is a scheme of the methodology of the project. I've crawled the social innovation project's web pages. I've pre-processed them by removing the HTML tags and extracting the most relevant parts of the text from their bodies. I then cleaned those texts and did some semantic analysis and passed those texts to the four summarization models that I've produced. I've then evaluated the models and picked up the best one, which was then used to produce the summaries for the NOMAC database. Speaking of the NOMAC database, here is some statistics about it. 5,000 projects, less than 2,000 classified as social innovation ones, less than 1,000 with an active web page, and less than half than that actually containing human summaries. There's also another dataset of around 150 human annotated summaries that I'm using for one of my models. So before proceeding with the models, I just want to say some key facts about um, how text summarization tools works. So in order to build a text summarization tool that produces extractive summaries, it has to be trained on such data, and unfortunately the summaries in the dataset are written by humans, meaning that they're mostly abstractive ones. So in order to generate extractive summaries, I'm taking the sentences from the original text and the sentences from the abstractive summary, I'm embedding them into vectors, doing cosine similarity, and then setting a threshold of 0.8, and if a sentence passes this threshold, it gets added to the extractive summary. So now I'm going to talk about the models I built. The first model I implemented was deemed to be the the most recent state-of-the-art extractive text summarization tool called SummerRunner. It was produced by the IBM Watson team, and it's a neural network based model utilizing two gated recurrent unit cells, the first one working on word level and the second one working on sentence level. I've trained this model using the CNN Daily Mail dataset and then performed model fitting using the NOMAC dataset. And Now, when you pass pre-processed text to it, it generates a short summary, which unfortunately is too short because most of the summaries are roughly around 15% of the original text, and unfortunately this model seems to be quite sensitive to noisier input. So the second approach I did was utilizing SVM classifiers. I took all the existing summaries, pre-processed them, created bag of words, calculated TF-IDF scores, and used this data in order to train an SVM classifier. So now when you pass a pre-processed text through this classifier, it classifies for each sentence if it should be included in the summary or not. And this one tends to produce quite large summaries, often around 80% of the original text length, but it's great because it really manages to filter out noisy data quite well. The third approach is utilizing the annotations dataset that I talked earlier about. Here I'm building 4 SVM classifiers, each one for each of the topics that the annotators used. The topics were objective, actor, innovativeness, and output. And now when you pass a text through those classifiers, each one of them classifies a sentence based on each of those topics, and the summary is formed by taking the top two sentences from those classifiers, but also preserving the order that they appear in the original text. And the last approach I've done was proposed by my second marker, Carol. Thank you for this. This one is a combination between the first and second approach. So I'm using the second approach first in order to create a crude summary and filter out all the noisy data, and then pass this through to the summary runner in order to generate the summary. This model seems to work quite well. Now let's talk a bit about the evaluation. So first I started by doing this manually, but as you know, it's a tedious job. So I then decided to implement the most widely used summarization metric called Rouge. This tool works by comparing n-grams between texts. As you can see from the table, the first and third approach seems to give the best result, and what is interesting to note is that the fourth approach, which is utilizing the first one in itself, has the lowest rating. The next evaluation I did was using the NOMAC ontology API in order to extract topics from text, and then just do topic similarity between the topics extracted from the original text and the one extracted from the summary. As you can see here, the second approach seems to give the best result, and this is normal because it tends to produce the longest summary, so the probability of having all the topics in it, it's uh, the highest. And then I've done one more metric utilizing LDA for topic extraction and then doing similarity. As you can see here, the most matching topics are found with the second approach. However, this classifier is also producing the longest summaries as mentioned. The fourth approach is performing similar matches with much shorter summaries being generated. And here is the online tool that I built for evaluation. So it's an interface where a user can log in and score the performance of the summaries produced by each of the models that I've discussed, and he can also annotate sentences that should or should not be included in the summary. This tool was given to the business students of the University of Strathclyde, which are also part of the NOMAC project, and to some students of the University of Manchester. Here are the results collected from this tool. As you can see, the second approach is still has the highest score. That's why I decided to develop a formula that penalizes longer summaries and boosts the score of shorter ones. And utilizing this formula, as you can see, gives the highest score to the third approach, and that's why I've used the third and fourth approach in order to generate all the summaries in the NOMAC database. I just want to mention that all the work here is accepted as a full conference paper to the NLDB 2019 conference. Thank you.